This is a problem of perturbation theory. The problem says the normalized eigenstate of a particle in a one-dimensional potential well is sin x equals to root over 2 by sin n pi x by a, and the particle is subjected to a perturbation which is given by v prime x equals to v0 cos of pi x by a. I'll have to calculate here the shift in ground state energy due to the perturbation in the first order. So the first order perturbation is epsilon 1 equals to psi v prime psi. Psi is given by root over 2 by a sin pi x by a. So this is psi, v prime is this, and psi is this. Psi and psi dagger both are the same, as this is real value. So for ground state we know that n equals to 1, that's why here n is put as 1, so this becomes sin pi x, sin n pi x becomes sin pi x by a. Thus the integral becomes this. Here we'll have to put, as this is sin square pi x by a, and here cos pi x by a is the perturbation part, so we can put sin pi x by a equals to t, and then the integral changes. If sin pi x by a equals to t, then by differentiation we can get pi by a cos of pi x by a equals to dt into dx equals to dt. So only cos pi x by a into dx equals to a by pi. This pi by a, if goes this side, then this becomes a by pi into dt, and the limits of the integration changes. When x equals to 0, then t equals to sin pi x by a equals to sin 0 equals to 0. When x equals to a by 2, then t becomes sin pi x by a, that is pi by a into putting values of x here as a by 2, this becomes a get cancelled, sin pi by 2 equals to 1. So the integral becomes epsilon 1 equals to 2v0 by a, 2v0 by a, 0 to a by 2 becomes 0 to 1, sin square pi x by a becomes t square, and cos pi x by a dx becomes a by pi into dt. Here a by pi comes out of the integral, and thus becomes 2v0 by a into a by pi, 0 to 1 t square dt. A get cancelled, 2v0 by pi, 2v0 by pi. This value of this integration t square dt equals to t cube by 3, and the limits of the integration as usual 0 to 1. So now this becomes 2v0 by pi into putting the value of t as 1 cube by 3 minus 0 cube by 3, that is 1 by 3. This becomes 2v0 by 3 pi.